Okay guys, welcome back to my channel, and today we will look at pigeonhole principle in a fun, intuitive and an applied manner. So first let me introduce the essence or the main purpose of the pigeonhole principle, or in real life how will you understand that pigeonhole principle might give you the solution that you are looking for. So the pigeonhole principle, we will go to the next slide first. I will tell you first what the theorem says. Okay, so what you have n pigeons, and these pigeons have to be distributed into k holes, and these k holes are less than the number of pigeons, or the condition is that your n is greater than k. Okay, so there can be multiple possible ways that you can distribute the pigeons into the holes. So I will number the holes as 1, 2, 3, 4. There might be a case where all of the n pigeons are placed in the first hole only, and remaining holes they remain empty. Or another possible way is we can fill half of the pigeons in first hole, rest half in the second hole, 3, 4 remains empty. So similarly there can be many ways that you can distribute the pigeons into these four holes, these k holes. Okay, the general is k holes, but what the pigeonhole principle says is something will be always true no matter how you distribute the pigeons into these holes. And what is this thing that is always true? Let us see that. So we will move to the next slide. Yeah, so we will move to the next slide. Okay, I'll erase the screen first. Okay, yeah. So that's something that remains always true no matter how you distribute the pigeons, n pigeons, where n is greater than k, into these k holes. There you will always find a hole. You will always find, these are k holes, 1, 2, so on till k. There will always be one hole where the number of pigeons will be always greater than equal to the greatest integer function of n by k. It will be always be true no matter how you distribute. So let us see an example. One example, you can distribute it. All the pigeons, n pigeons, I am writing it like this, are in first hole, and remaining holes are empty. Okay, so on the k holes are empty. So this is trivial. Then you can definitely see in first hole there is at least one hole. So this hole number 1 has more than n by k pigeons. They have all the n pigeons. So this is really true. Another distribution can be n by 2 pigeons in the first hole. In the second hole also you have n by 2 pigeons, and remaining are 0. So in that case also at least one hole is there that has greater than equal to n by k pigeons. Okay. Okay. So we can take an example, numerical example, then it will be more clear to us. Okay. Let us take the k as 4 and n as 10. Okay. So we have 10 pigeons and we have 4 holes. So now the k is 4. Okay. 1, 2, 3, 4. We have 4 holes. So what would be greatest integer function of n by k? That would be 10 by 4. 4 2s are 8, right? That would be 2, right? Yeah. So the theorem says no matter how you distribute these 10 pigeons into these 4 holes, there will always be minimum one hole which will have greater than or equal to 2 pigeons in this, 2 or more than 2. It is not true that uh, there you will not find any hole having less than 2 pigeons. Okay, the one possible distribution can be the half, that was I was saying, the half of the pigeons are in first hole, that is 10's half is 5, and second has 5 pigeons in this and remaining are empty. Then you are actually finding at least one hole there where you have two or more than 2 pigeons in this. So we can see the proof of this theorem as well in a very quick manner. Suppose we have the general, the k holes, one, one hole, two holes, so on. We have the k holes. And we assume that there is no hole with n by k, GIF of n by k pigeons in it. That means all the holes have less than n by k pigeons. So we have less than n by k pigeons first in first hole, sorry, less than, and less than n by k pigeons in the second, so on, less than n by k pigeons in the kth hole. So if you add all these k terms, what you will get? K into n by k less than k into n by k are the total number of pigeons. So number of pigeons, that becomes less than n, but that is incorrect. So we can conclude you cannot have any distribution where in any of the holes you have less than n by k pigeons. Okay. Okay. Now we will move to see another example of application of pigeonhole principle. Okay. We'll move to the next slide. Okay. So the question is that you have an equilateral triangle where each of the sides are 1 unit in length. Okay. And you have inside this equilateral triangle, you have 10 points distributed inside it. Okay. You have 10 points like this: 5, 6, 7, 8, 9, 10. And what you have to prove is there will be at least 2 points always. Okay, always, whose separation or the distance between them is less than equal to 1 by 3. Always there will be 2 points. You will find 2 points no matter how, wherever these points are, wherever they are, how they are distributed, no matter, you will always find minimum 2 points whose separation will be less than equal to 1 by 3. Now, how to proceed with this question? Now, as this question is saying the separation about 1 by 3 units, I'll erase it. Okay. So, as this question is saying about separation of 1 by 3 units, we will change the color as well. We'll make it maybe green. Okay. It is talking about separation and 1 by 3 units. That means, and this equilateral triangle, each side is 1 unit. Correct? So how we will get 1 by 3 units? If we divide this, all the sides, in 3 equal parts. So we will divide it into 3 equal parts. Okay? All the sides. So we will get, otherwise we cannot know how the distance is going to be 3, 1 third, right? So I will use a different color. This is not very visible. So we'll use blue. Erase everything before. Okay. Now we will change the color to blue. Okay. So we will divide this length into 3 equal parts, all the sides. Then this distance would be 1 by 3, right? Now we will join, okay, this is not at the same height. Erase it. Okay. Now we will join these lines to create equilateral triangles inside this bigger equilateral triangle. Okay. Okay. Now this in this question it's hard to identify the what are the pigeons and what are the holes. In pigeonhole principle it's important to identify what would be the pigeons and what would be our holes. Now in this question you see the now you can see this whole area as holes, right? And this length is 1 by 3, this length is also 1 by 3, it is ensured, right? And inside these holes we have to distribute the pigeons inside it, right? Okay, let's see, we'll change the color to sky blue. Yeah, so we have to distribute inside these holes the 10 points, right? Now how do we identify if there would be at least 2 points all the time, no matter how you distribute these points inside these holes, that the distance between them will be always less than 1 by 3. Okay. So I see how many holes we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have total of 9 holes. And our number of points, okay, I will change the color. And our number of points or pigeons are 10 and our holes are 9. So that means I will get at least one hole with greater than equal to n by k. N is 10 by 9, the seal of it. So that would be 1. Oh, yeah, minus a 9. Yeah, that would be greater than equal to 1 pigeon. If we assign one pigeon to every hole, worst case, if we have more pigeons, more points inside one hole, then everything is proved. Definitely we will have 2 points. If 2 points are inside this one hole, the distance between them is definitely less than 1 by 3, correct? But across the holes, but if we see across the holes, if one pigeon is placed over here and one pigeon is placed up over here, the distance is greater than 1 by 3. So in every distribution we can prove there will be 2 pigeons, 2 points inside one hole at least, then the question is proved then. So if I see the worst case distribution where I give 1 point in every hole, okay, so how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the worst case distribution. In all other distributions, there will be minimum 2 pigeons inside the same hole. Just think about it. Pause and think about it. Now, I have assigned 9 points inside each hole, and distance between across these holes is greater than 1 by 3. But I have one pigeon left, and that has to be placed inside a hole where already 1 point is there. So definitely, no matter how you distribute the points inside this equilateral triangle, there will be 2 points whose distance would be less than 1 by 3, and it is proved. So in pigeonhole principle, it's not very easy to identify what would be pigeons, what would be holes, and we are talking about all in no matter how you distribute these points into this inside these holes, there would be at least one hole minimum whose number of pigeons would be greater than equal to the greatest integer of n by k. So that is the pigeonhole principle's essence. Okay. So now we will move ahead. So I will clean the screen first. So that's all about pigeonhole principles and how to identify it in questions and how to apply it in real life. If you like this video, please share it with your friends and subscribe to my channel and share your feedback in the comment section below. The areas to improve or your thoughts. I would be happy to know about it. Happy learning. Bye bye.